Alright, so let's do a problem with the limit definition of the derivative. And so, to get started here, what is limit definition of the derivative? Well, let's recall that the limit definition of the derivative is just, it states that, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so this is the limit definition right here. Now, what function would we like to evaluate? Well, how about let's evaluate f of x equals, we'll make this a rational, first-degree rational polynomial function, or rational first-degree polynomial. So, 1/2, let's make that an actual 1/2 x minus 3/5. Alright, so this is the function we're going to want to evaluate using the limit definition. F of x equals 1/2 x minus 3/5. So let's go ahead and get started here. So what do we mean when we say let's use the limit definition? Well, that just means let's go ahead everywhere we have an x, and we'll plug in an x plus h for this portion, and then we'll just rewrite the original equation for the right-hand side of this difference. So, what's this going to look like? Well, we're going to have the limit as h approaches 0, limit as h approaches 0 of 1/2 x plus h minus 3/5 minus 1/2 x minus 3/5. Okay? All this over h. Okay, great. So, what is this going to equal? Well, now we're just doing some algebraic stuff. We've got, once again, the limit as h approaches 0. And, of course, we have to remember to write this limit as h approaches 0 every time in order for these expressions to actually be truthfully equivalent. So, we're going to continue just to still have our h on the bottom. H, of course, is the same thing as just a delta x. So, if you want to write it that way, that's completely your prerogative and will not change anything at all, so that's also totally fine. And so, more importantly, obviously, we have an h on the bottom, but what do we have in the numerator? Well, we're just going to have 1/2 x plus 1/2 h minus 3/5 minus 1/2 x plus 3/5. Why plus 3/5? Well, look, we have a negative here, but we have a negative times the negative, which is just positive. So that negative negates this negative, making that positive. So we'll say plus now. Okay, that's 3/5 on the top over h. So this is now, we're going to need to algebraically and arithmetically simplify the expression in the numerator. First off, well, all of this, I mean, if you just want to go ahead and look at it piece by piece, what do we have? Well, right off the bat, I notice a 1/2 x, and then I notice a negative 1/2 x. So how about let's get rid of these. We cannot worry about them. We just kill both of those. And then I see a negative 3/5 and a positive 3/5. So we can get rid of, let's make this a little bit better. Say, get rid of this. Get rid of this, then we get rid of this, and we get rid of this, negative 3/5, positive 3/5. So now what are we left with on the top? Well, we're just left with 1/2 h, right? So this is just the limit as h approaches 0 of 1/2 h over h. So we have the limit as h approaches 0 of 1/2 h over h. And now the term delta x, or the term h, because h is going to 0, it just divides out, and we can actually calculate the limit, right? So what's that going to look like? get rid of the h, get rid of the h, and now we're going to have the limit as h approaches 0 of 1/2. Well, this should not be that hard to work out. The limit as h approaches 0 of 1/2, well, it's just 1/2. So, 1/2. And we're done. This is the derivative of that function. So, 1/2 x minus 3/5 prime is just 1/2. We're good to go. That's all there is to this problem.